Hi everyone, Engineer Liu here. Welcome to another C tutorial. On this tutorial, I would like to talk about how we can write and work with text files and see how we open them, read from them, print on the screen, and so on. So first things first. On this tutorial we'll go give a little project, an example of how we can make a clone of the cat tool from Linux. So it simply prints out the contents of a file on the screen. We specify the file, the relative file path, and then it basically prints on the screen, and we're going make a clone of it. So that's what we're going to do on this tutorial. So first things first. So I already created the text file which the C file, C source code, the boilerplate for which we'll be working. So in C, the files are handled by what's called a file descriptor. So it's a pointer in memory, and to how C, the compiler, will identify the file to be opened. And basically we declare like this: file fp. Fp stands for file process, I believe, or file. Actually, usually uses file ft for file descriptor. And when we're working with a file, we will try to open it, right? So basically we use the fopen function, and then we specify let me check, right? fopen it returns a pointer to the file descriptor we are using, and basically its arguments are the path name and the mode that we want to read file. So we can open as a pen mode, a read only mode, a write mode. There are several ways we can open a file. And then afterwards we have to close the file, pretty much like we have to deallocate memory at the end of a program. So once we're done working with the file, we then close the file, right? So let's try it out. We simply say ft equals fopen. We can use a test.txt, and then we simply read from it, right? And then once we're done with it, we can simply close like this. And so this is basically the main basic functionality for working with a file in C. So in case this file doesn't exist, it will throw an error, so it will equal to null, right? So if ft equal null to the null pointer, we can print I'll be using, instead of printf, I'll be using fprintf, so we will see more often. So we print the standard error. An error occurred while opening the file, and and then we exit the program. Instead of using one, we can use a macro called exit failure. So I believe this is equal to 1, but it can vary from machine to machine, so it's better to use this macro here. So when the compile will compile our program, and then we'll substitute. Okay, So let's try it out. As you can see, we don't have this file here, so I believe it should throw an error. So let's compile main.c. So we compile and then we run, and yeah, an error occurs while opening a file because it doesn't exist, right? So let me just insert here a new line, compile and run. Yeah, so let's create this file, touch test.txt, and then let's say hello world, just to give you some content. And then yeah, we compile, run, and so we don't get any errors, right? So how we can print the contents of this file? Well, first of all, we need a buffer to do this. So yeah, we're actually going to be needing a buffer. But before I get into printing the contents of the file, I would like to show you how we can write to a file. So yeah, let me edit this, and yeah, just leave it blank. And so let's say we want to print an argument is less than 2, printf to the standard error. Let's just say printf usage main string. Okay, and then we simply exit the program. Else we then open the file, and then we can print to the file, or we can write to the file the string that we pass as argument, right? So yeah, we can use fprintf for this. So we pass the file descriptor here, file string, or whatever you want to call it, and then we pass argv1, which in this case will be the string we are passing as argument. And then yeah, we close the file. So that's pretty much it. So gcc a format, not the string literal, and no format arguments. Oh yeah, we have to, I believe, to pass it like this. Yeah, so yeah, so we run. Yeah, we forgot to pass an argument to the file. Actually, we would say my name, Leo, my nickname. So yeah, let's check it out. Cat text.txt, and it's blank. Yeah, of course it's blank because we will open the file as read only. So yeah, it won't work. We have to open as write mode, and then we compile and run. Yeah, so I believe now we have, yeah, it worked, right? There's, I believe, still another option for writing to a file, like we can use the function called fwrite. Oops. So yeah, basically function fread, the memory items of data, it's the string pointed to this by string obtaining an allocation. So yeah, I believe this will be a pointer. I guess a pointer to where we're reading from. In this case, would be string, and then we pass the size of the string in bytes, and bytes and memory be items of data. Each size bytes long to the string pointed to byte string. Okay, so yeah, let's try using fwrite instead of so I will edit first this file here, test.txt. I'll leave it blank like this. So, and instead of fprintf, I'll be using fwrite, and I believe we pass argv1, the size of argv1, the number of elements we are writing. In this case, I believe it would be 1, and then ft for a file descriptor pointer. Okay, so we compile, yeah, and run. Actually, I'm not compiling with the warnings flag, so okay, so main.oleo, and then let's check the contents of file. Yeah, leo yeah, I believe we have a buffer problem here. So yeah, let me check right here. Size of, actually here it would be string length, I believe. So I have to include string.h. Yeah. So let me edit this file. So yeah, we got a problem of buffer overflow here. So compile, run, and then cat. Yeah, it was a problem of a buffer overflow, right? So we have two options for writing to a file. So we have fprintf and then fwrite. I personally prefer to use fprintf. Then we pass the pointers of the file, the string, the formatted string we want to print in, and the arguments. So yeah, I'll stick to those. And now we'll be going to our project. Which will be doing a clone of the cat functionality tool in Linux, which simply prints the contents of a file. So here it will be a file name, and then yeah, we simply open argv1, right? And yeah, actually here I'll create another project, and fopen test.txt, and leave this as an example of writing the contents for a file, just to have two examples in the, yeah. So and we run with the argument, and yeah, so it's working. So I would say create a dir here, example 1, and then example 2, right? So I'll copy main.c to example 2. Okay, and then move main.c, main.o, and test.txt to example run, right? So we have two examples on this video, this tutorial, right? So yeah, and now we have to modify this function. So here it will be the argument would be the file path, and then the file path is what will be open here. So it will be argv1, and if ft equals null, we throw an error, and then we exit, and then yeah, I guess so we can eliminate these lines here, so we won't be printing anything to the file, and we will open it on read mode, right? And the basic functionality that we want is read from the file and printing on the screen. So for that, we're going to be needing a buffer. So I'll define a size for our buffer of power of 2, right? To optimize memory allocation and so on. So basically here we're going to be using a function called fread. So yeah, oops. So fread returns a number of bytes read to a buffer, a size t, which I believe is the size of our buffer, and no, actually is the size of the pointer, and then the size of the buffer, yeah, and then the file stream. Okay, I believe we got another option for reading from a file. Yeah, I'm not sure right now. Yeah, I believe we have fget. Let me check. Fget string. So yeah, fget gets the next character from the string and returns it on sign chart cast int. Okay. So yeah, we got two options here. Yeah, we also have get line, and yeah, I think I'm gonna implement this with fread, but really we got several options here for implementing this. So yeah, I'm gonna stick with the fread, which is similar to the other function that we worked it. I'm not quite sure right now. So yeah, let's declare a buffer, char buffer size, and also we're gonna need the number of bytes read, so it will be a size t. Remember, size t is an unsigned integer. Yeah, let's call it bytes read, and yeah. So while the bytes read is different than 0, which means we reach the end of the file. So bytes read, let's do it like this. So do while bytes read is different than 0, and let's just initialize this to 0, and then we assign it like this: bytes read is equal to fread, the buffer, the size of char, which is the size of the pointer we are using, and then we pass the size of the buffer, and finally our file descriptor, right? So I guess this is correct. And then yeah, now we got our bytes read. We can print to the standard output. Okay, so I guess we could use printf, but we can also use pref, since I'll be using fprintf all throughout all the file. I'll be sticking to fprintf, to the standard output, and then we print a string, which will be our buffer, and then a new line, I guess, and we pass simply our buffer, right? I guess this is correct. Yeah, so we would do this while bytes read is different than 0. Okay, so we write and quit, and let's just call this can call this main, but yeah, let's rename it to cat clone.c. okay, so gcc cat clone, all warnings. Yeah, we're going to be needing a file to test this, so cat clone.c, cat clone.o. So yeah, we got a binary, so let's create a file, test.txt. And actually we can print, we don't need this file for testing, we can simply print the contents of cat clone.c. So let's pass it as an argument, cat clone.c, and yeah, we got a buffer overflow here, I believe. So yeah, it printed twice. Let me check right here. Yeah, so it's probably a problem here. Oops. Okay, bytes read. Size of char, size of buffer, then we print to the standard output. While bytes read is different than 0. Okay, it will do this once. Yeah. It's doing it more than once. It should be doing only once. So it's a problem with our logic here. And for buffer size, yeah. So is there an option? Let me check. We have this other function like man fgetString. So fgets, we pass a buffer, the size of the buffer, and then a file string. So let's try with file get string. yeah, so f gets string, and then we simply pass the size of a buffer, and then the file descriptor. Size t. Okay, so here we have to declare this as an int. Yeah, char makes f gets string. Okay, so f gets reads also size and then starts the then starts for end of file or a new line. If a new line is read, it is stored into the buffer. Terminating null byte is stored after the last character in the buffer. So here, yeah, we got a warning. Makes integer from pointer without cast. So let's see if it works despite our warning here, because it doesn't return the same thing as the other. So yeah, here we got it working properly, I guess. Yeah, it's printing. Oops, it's printing little lines all over the place. Let me check something. Yeah, so we don't need this new line anymore. Can remove it, and we compile and run. So yeah, now it's working properly. And we got this here, which is weird. Yeah, it printed twice. Yeah, let me check something. Actually, we could do it like this, like bytes read equal to f gets buffer size of buffer, and ft is different than 0. Then we remove this one, and we simply printf standard output string and then the buffer, and we can remove this line here and only stick with a while without a do while loop. So I guess that's more straightforward. So we compile. Okay. That seems to be the problem here. Bytes read. Okay. So okay. Left hand. Oops. Size off. Okay, so we only got this warning and we have to correct it afterwards. So yeah, let's try running. Nevertheless, yeah, now it's working properly. We only got that warning because this function f gets returns its type char. So yeah, we have to cast it to an int, right? So let's do this. And we basically have made already a clone from cat, right, from Linux. So we have to cast this to an int, right? So let's try compiling. Cast from pointer to integer of different size. Okay. So this must be, it returns a char, and the char is 1 byte, so we need a integer of 8 bytes. And yeah, we're going to be needing standard what was the name again? So here it's actually a uint. It's standard int, and here 8t. Okay, so it's 1 byte, 8 bits, 1 byte, so it's unsigned. We convert from char to an unsigned int, so yeah, I believe it will work now. And yeah, we are casting it incorrectly here. So we cast to an unsigned integer of 8 bits, which is 1 byte, a different size. So yeah, we got the char. I guess it shouldn't be unsigned here. Or we can let me try something. While we check for end of file. Yeah. What is he complaining about here? Fget size off. Yeah. Pointer and integer. Okay, let's try running nevertheless. Yeah. So it should stick to bytes read. And yeah, I guess here we should use a char for bytes, and yeah, let me check the again. So char fget, so yeah, it returns a point. Store an automated byte. Yeah, let me use it as a pointer to see if it stops complaining. Yeah, so it's, I guess, yeah, it worked. So we had to instead of using an integer, we had to use a char for checking for a pointer for the bytes read. But the implicit cast from char to integer worked nevertheless, but we should avoid things like that when programming with C. So yeah, we managed to write, let me get rid of this since we won't be needing, and also a string, and I guess standard lib, and yeah, we're gonna be needing standard lib here. So yeah, so basically we managed to work with files, read and open files, read to files, and we managed to create a clone of the cat tool in Linux. So hope you guys like this video. Don't forget to like, subscribe, and comment, activate notifications, and see you next time. Bye.